Well, good morning, good afternoon, and good evening from wherever you are joining us in the world. And welcome to the third, and I don't know how many editions we're going to have of this, Scott, but the third edition of Market Brew's Fireside Chat. We are super excited to share some really cool and exciting insights around embedding clusters. But before we do that, just a quick note. As you're joining us, make sure you stay at the end of the call because we've got a super fun video where Scott and one of our team members actually breaks down embedding clusters a little bit more detail. So if you want to have a masterclass, stay later, buckle in, and get ready to go. Well, a couple of things before we get started, before we talk about embedding clusters, a couple of introductions. My name is Steve. I'm the head of business development here at Market Brew. My background has been in pastoral and biblical studies, so I know a lot about people and a lot about a book I don't think a lot of people care about. So nonetheless, I've been a sales professional since 2016. Was in Verizon business group for almost 5 years. Goodness, it's been a while. And then was recognized on the Marquis Who Who. I have my best coffee in the world brewed by myself and handlebar mustache done by myself. So heading over to Scott, who is the brains behind my beauty. Carnegie Mellon grad, an incredibly humble co-founder of Market Brew. He is a Google for Entrepreneurs advisor. And the cool part is that he's actually written a couple of utility patents around transparency in the SEO space, which is beautiful because I jokingly say, the only way you find out what's inside the black box is when the airplane crashes. So why not open up the black box a little bit earlier of Google with Scott and understand how Market Brew could be a tool for your agency or for your enterprise business. So let's set us up for today. Market Brew is the only truly predictive SEO software that is out there. Many claim to be AI driven, but the reality is most of them are all glorified Google scrapers, where in this dynamic, we are actually a proprietary search engine model that Scott has built that is a layer between a search engine. So whether you're trying to rank on Google or Bing or Yahoo or whatever search engine you desire, utilizing Market Brew can help give you accurate and clear forecasts, giving you the ability to go to your executive team and ask for funding for a purposeful reason, and really unlocking that black box of Google that has been locked for a lot of years. So, Scott, I love bragging about you. Let's start talking through the SEO landscape. Things are continually changing, and it
Yes, they
feels
are.
like Google is more volatile than ever. We've talked before about TDEF, IDF, and how there's been a number of different iterations in the SEO space. And now that we're on this embeddings dynamic, I would assume that a lot of us are still learning about how AI and embeddings are going to fit in together. So, and I think all of us have experienced the pain of being in SEO, of going, man, my strategy's not working. I'm trying really hard, and I need to be able to answer for my strategy. So, Scott, can you open us up today and talk to us a little bit more about how the landscape is changing and how our viewers can benefit from it?
Sure. Thanks, Steve, for the introduction. Everybody, welcome. Glad you're here. My goal really is just as a search engineer to help you understand the landscape today and how the technical side of things sort of function. And hopefully that turns into lots of ROI for you guys. One of the things that we're going to be talking about, obviously, is using our software at Market Brew, and that is a search engine model, right? So the cool thing about search engine models is think of it as a chameleon search engine. So you can feed it any rankings and it will find the features in that neural net. We call them families of algorithms, and it will weight those appropriately so that our search results behave the same way. We had this massive discovery in 2014 called particle swarm optimization. It's a genetic algorithm that when paired with this search engine model approach, it allowed us to sort of create this chameleon search engine. So that's great. We can sort of have a sort of a model of what's happening here. But what happens when Google changes or shifts? Well, the beauty of this is that we can see sort of the legacy arc of what's happening. And today we're going to talk about text classifiers, right? So there's different components to every search engine. That we're going to skip the link graph stuff today, but we're going to talk about text classifiers because that's what's affecting SEO so much. And with SEO sort of changing seems like every month, a lot of the tools out there are going to start becoming unusable, and it's a fail silent thing that's happening here, which is even more deadly because you don't know when the tool stops working. So the cool thing about this search engine modeling approach is, and when I'm going to use this, and I'm going to show you a free tool today to use, is it's always able to adapt, right? As Google zigs and zags, we can do the same thing. So the software inherently is always up to date. So let's talk a little bit about sort of what is happening around embeddings, and why is all of the industry kind of scrapping to understand, why certain chunks of parts of the site are falling off of the map. So this is all based off of a new 4th generation based text classifier called embeddings. And just briefly before we're going to go into this, we're going to talk a little bit about what embeddings are from the ground up. If you guys haven't watched our previous fireside chats, we went into this in detail. I'll just kind of skip through this very quickly. But you can see that embeddings are just taking a piece of content and converting it to a vector. And this is just a point in space, you can imagine, that is sort of taking up this multi-dimensional space, right? And so for any page on the internet, you might have a bunch of different points in space for that individual page. In Market Brew and our search engine models, we chunk the content up into a fixed length. There's a whole theory behind the why we did this. And so essentially you see chunks of embeddings. You have these embedding chunks for each page. You can do this many different ways. That's the way that we believe is currently the sort of the standard way of doing this. And you can see that in each of these pages, you can do these mathematical calculations now, because these are just vectors, right? It's just a mathematical matrix calculation. We have a thing called k-means, which allows us to group these points in space into different clusters, right? And so we can say, give us 3 clusters on this page, and it will go find these 3 clusters, and whatever the one that has the most embeddings in it, we'll consider that what the page is really about. It's that semantic space that gives us the ability to understand what the connections and relationships are from one page to another. So that's the idea behind embeddings. And I'm about to show you this, but Steve, you're going to realize there's massive sites that were sort of using this strategy of what we call Parasite SEO. And this is really something that is going to shock a lot of people with some of the graphs that they're going to see here. But I wanted to get your impression on and get a chance to answer any questions about embeddings or anything about that before we get into sort of what's going on in the industry right now.
Well, I think when it comes to embeddings, maybe there are newer SEO specialists on the call who are looking to learn. I think the dynamic of embeddings and vectors takes us back to like 11th grade, trigonomics. Like how in the world are we trying to understand how text classifiers and neural links come together? So could you explain a little bit more about what the correlation is between the two, so that our viewers who maybe aren't as tech savvy as you can feel comfortable about how Market Brew can analyze their tech stack?
I think the embedding clusters, it's really just a version 2 of an entity-based SEO. Before an entity-based SEO, a lot of people are already familiar with that for the last 8 years, where we deal with finding what the top topic cluster of the page is. And we start by extracting the entities on the page, disambiguating those entities and connecting them to a graph, right? Some sort of knowledge graph. And then we can look at the relationships of all these entities and come up with a best guess of sort of what the page is and what semantic space that page takes up. With embeddings, you aren't looking at one individual keyword. You're looking at a window of content. So it's the entire context window that it's sort of converting to that embedding. And if we use this approach called Siamese networks, SentenceBERT is a good example of this. So I'm sure many of you are familiar with SentenceBERT, which changed sort of natural language processing for good in the last 6 or 7 years. It all started with this paper called Attention is All You Need in 2017 that introduced the idea of a transformer network. But essentially we came up with this way of converting these chunks of content to points in space. And then we have these cool mathematical tools. I showed you the k-means, but we also have this thing called cosine similarity that can measure the distance between these points. And it turns out that the distances that are close by mean they have a relationship. They have a close relationship in some form or fashion. So.
No, that is really, really helpful. So let's let's shift a little bit. Let's talk through the risk of Parasite SEO. As we promoted this, I was like, okay, the Halloween edition. When I think of Parasite, I think of that good old Korean horror flick Parasite, and like kind of the exaggeration of what that is. So I'm assuming that Parasite SEO. I mean, there's been a lot of websites that have been like lower quality websites that exploit loopholes and then get rewarded by that within Google. So what are the risks of Parasite SEO, and how can we as search engineers combat this with embedding clusters?
Yeah, great question. So the problem with this time around is that it's affecting very big sites. So these aren't just sort of fly by night sites that are set up or affiliate sections of sites. These are like massive sites that have decided to create like a health portion of their site, or anything that is not necessarily surrounding the main topic of that site. And up until now, we really, as search engineers, didn't have a way to measure this, right, very accurately. Specifically, entities was the closest we got, but with entities, we sort of run into a wall because it's all dependent on the knowledge graph, which is human curated and can also be sort of manipulated. So, and that outside of sort of the U.S. North American knowledge graph, those graphs are way behind the one in the U.S. So, for applying these entity-based SEO techniques, it didn't really work as well as the one sort of domestic here. And so we quickly switched over to sort of this idea of using embeddings in the same fashion. This time only mathematically we're calculating these clusters, and we can see sort of what the actual semantic space is in a very much higher dimensional space. Let's put it that way. And so what we're seeing today is, because we have these tools as search engineers, we can now apply them at scale. And we're seeing this now with Google. And obviously we've seen this, Steve, we've seen this for almost a year now. But now
Yeah.
everybody is sort of coming to, their senses and going, okay, there's something new here. And it's this new technology that Google is able to sort of look at, a site like Forbes and completely demote an entire subfolder. And it's not based off of like the URL subfolder structure or whatever. It's actually based off of the content, right? They don't think that the content belongs there. They think it should belong on a health site, right? And so basically what this is doing is it's providing Google the ability to remove any instances where these big sites will start these subfolders, and sometimes they earn revenue through that with a third party, and the third party essentially writes all of that content on their behalf. Whatever it happens to be, all of this stuff can now easily be targeted because we can go onto these pages and see that that page doesn't belong to the top site's embedding cluster, right? We can take all the chunks of content on the Forbes site and we can see, okay, this is the semantic space. We take an average of that top cluster. We call this a centroid. So it's just another vector in that cluster. And then in that centroid, we can measure the distance, how far away this page is from that centroid. And we can see that they're really far away. And so we just decide, okay, we'll write in Market Brew, we call it the top cluster similarity algorithm. And it's essentially just looking at whether it belongs to the top sites cluster or the top pages cluster. If it isn't, we just demote it. So you'll see this, and in the models, because they calibrate, we can tell when Google has it turned on. So we can see this top cluster similarity algorithm is very correlated with the overall ranking results. And we can see this across many different ranking results. So we started to see, early on in this year, we started to see this top cluster similarity algorithm really take off. And, a lot of people get caught up thinking it's an HCU update or whatever it comes out of the PR team's mouths. It's what we believe as a search engineer team is that this is happening because of this top cluster similarity. And of course, now, we have some PR teams at Google sort of confirming that. I don't even have the quotes in this screen right now, but out today and yesterday, they're basically saying that they have the ability now to see these things. So so a lot of shakeup is happening right now. I believe this will actually help small independent publishers. I know a lot of people are really down on that right now, and Google just had a meeting with all of them. A lot of people that bought tickets to go to the multiplex in Mountain View and just basically talk to them about it and give them their feedback. And Google basically said, look, we don't necessarily can't promise that those things are going to happen, but I think really what's happening is if they're able to do this to large sites and keep the sites on focus and not allow this sort of content that really shouldn't really belong to the page, that content's going to have to come from somewhere else. And I know a lot of people say, well, they'll just pull it into AI overviews. The way that they do that, we'll show you today with a free tool. So you'll be able to see and conform your assumptions to what Google bias is for your own site at the end with this tool.
Love it. Well then, so let's chat this. As I was thinking about this next section, I was thinking about like the previous dating lives that we've all had, right? How great would it have been if your partner, if you knew what your partner wanted, so that way you can just easily walk right into it and do what he or she would be wanting, whether you're at dinner or wherever, whether you're planning a vacation, whatever it may be, right? It's just so good to know what your other partner is looking for. For SEO, our partner is Google. Google's the one that is really where we are investing all of our eggs. So the challenge is, how the heck do we know what Google is biasing? Like, there have been so many people, Scott, who are frustrated because they don't know how to align their content with what Google is desiring. So, like that, dating analogy, how can we help anybody who's on the call understand how to align content with what Google is actually wanting without Google actually saying it?
Yep. So we're going to actually use a case study today, Steve, a recent one that we just did, and it'll just illustrate exactly sort of what you do from discovering that you have a potential issue all the way to implementing and realigning the content so that you're basically Google friendly at that point. So one of the things that we looked at here, and these are snippets coming out of or screenshots coming out of Brew's search engine modeling tool, which allows us to take these types of KPIs and put them into algorithms and see if they're correlated with the overall results. And if they are, they produce these tasks. It's basically based off of these leverage points in the model. So we will simulate what happens if you do this, what happens to the model then. And we can see in this one specific top cluster similarity algorithm task, that this chunk of content that was on this core set dresses page was not part of the top pages cluster. And so the first thing that it just kind of pointed out was, hey, we applied this to all the search result pages, or the landing pages in that search result. This is for core set dresses. And we found that the ones that were not in the top cluster were deranked. And so there was an actual correlation here. And so it bubbled up to the top of this task list. And as we start to go into it, you'll see, and by the way, we're going to show a live recording of this as we went through this at the end of this call. So if you want to, again, have sort of a master class and see the extreme details of what we were doing, stick around. It'll happen at the end of this call. But just as a summary of what happened, we have this page level cluster in number 3. And we can see that the search engine model told us what are the differences between these clusters. And we could see that on this page, the top cluster of content, or the top chunk of content that was coming back, was in fact their navigation. It was the top part of their site that was listing out all the different types of dresses. And we went, that's really interesting because, like, down in the body, we're talking just about corset dresses. Why wouldn't it just pull that content back first? And when we looked at it, we found that the content was more centered around dresses in homecoming and dresses in prom. And it was talking about all the events that you can do with your dress. And what we realized very quickly by using this AI Overviews Visualizer tool, which you guys will be able to access this at any time after this call, you'll be able to go in and see all of these cosine similarities with the corset dress query. So we could see all the chunks of content, and we found that it preferred when corset dress was being mentioned in the context of other dresses. So in other words, comparing to other dresses or comparing to features of other dresses. So what we did is we were able to essentially look at the recommendations in the search engine model, see what the differences were. And here we could go into the AI Overviews Visualizer. So you can see right here, the top snippet. Again, this is their navigation. And it had a 60.74% cosine similar. It was the top one on the page. And however, it was not part of the top pages cluster, right? You can see this is in blue. This is the cluster view in that AI Overviews Visualizer. So you can see the red is the top cluster. So this is what the page was about. It was about corset dresses, but in the context of homecoming and prom. So that was that semantic space. Up here, we were corset dresses in the context of all these other different dresses. And because the page really wasn't about that, then we got sort of tangled up into this top cluster similarity algorithm where Google looked at it and said, hey, this snippet really isn't representative of the page and we don't want it. So this is, and then you can see the main content was at 58%, mentioning all these things about corset dresses. And so one of the things that we could quickly see is that Google is appearing to be more attracted to the content is comparing corset dresses to other dresses. So let's make the page's main content about that, right? So we can simply ask the search engine model to make the page's content more aligned to the target embedding. And so you can use this in many different ways to, you can take the instructions out of the search engine model task and feed it into like a chat GPT. And this is the instructions right here, by the way. So it says, if you suspect that the page's top cluster is misaligned with your goals, here's how you could realign it with more focus on the target embedding, right? So we're trying to get the top chunk of content that is going to come back in like a snippets or in the context window of Google Gemini or AI overviews. We want that top chunk of content to be in the top cluster of the page. So we want to make the page about the top cluster that it likes, or the top embedding that it likes. And so to do that, it tells us, well, we can just refocus and make sure that when we're talking about dresses, we're going to talk about the different varieties and the different characteristics and comparisons of those. So we can just simply put this into, this is just an example. Here we're in a large language model, the one that probably everyone's used, ChatGPT. And you can see that we're just saying, make the content, we paste in the content that currently is on that page. And we say, make this content more about how corset dresses stack up against other dresses, not about how it fits into homecoming and prom. And I even threw in the top cluster needs realignment. Of course, it's a large language model, so it knows exactly what I'm talking about. And so here we can see that here's a revised version, and we can just paste this into our AI overviews author. So you just go in there, take out the old content, paste in the new content, click update, and boom, we can see exactly what's happening. We can see now that the navigation is not the top piece of content. It's this one down here. It's already surpassed this. So this will be the chunk of content that Google would prefer to pull back in its snippets or AI overviews result as a citation. And we can also see that now the surrounding content, which is the page's content, is about that specific snippet. And all we did is we essentially said, realign it and stop talking about prom and homecoming so much, but talk a little bit more about how it compares to other types of dresses. So Steve, we don't have any, exact proof of this, but this page jumped from 100 to 38 in 3 days after we went ahead and made this change. And obviously this is not something that we would see happen that quickly. So it's possible that there are some other circumstances, but they were hurting pretty bad on this page. And as soon as we realigned this, it started driving that ranking straight up. And we can see this also in the model. So we can see when we do these things in our search engine model, it shows those rankings improvements. So it's not like it's a surprise for us, but it's just the speed in which it happened was a little bit surprising. But yeah, so that's essentially how you would use this embedding approach to understand whether or not this is affecting you. And then obviously Google will, or in this, the search engine, if you have a search engine model, you can see sort of an example of what Google likes. So this is obviously a little cheat code. You can just feed this in and say, hey, this is the realignment that I need. But the AI overviews visualizer gives you that ability to see exactly what's happening throughout the entire page. Also, if it's a site level cluster similarity, like what's affecting Forbes and all these other sort of the subfolders that are getting hammered right now by Google. So all of that stuff is available in that AI overviews visualizer, and you can see it in the down there. You can see, go to marketbrew.ai, click on free tools and free SEO tools and guides, and that AI overviews visualizer is in there along with a lot of really cool tools. We're going to be growing that over the year. We have just introduced a cosine similarity matrix, so you can try all kinds of different keywords and see how those heat maps look against all of your page's content. So I know it's not always just one keyword, so we want to look at a family of keywords and how that would react. And then obviously, if you guys are interested in having us help and build these search engine models for you to see where we actually need to realign, go ahead and click on request a demo, and Steve and I can definitely set something up for you guys after the call. So
For sure.
yeah, so Steve, what do you think so far?
Well, I think it's really, really helpful because at the end of the day, we're all looking for results, right? In the SEO space, we want to see those results change significantly. So the fact that we have a case study where, yes, we predicted that it was going to increase, but the fact that it increased even more than what we predicted is a beautiful testament to how this tool can be an amazing help for a lot of people who are in this space. I know we're going to show kind of that dynamic later in the call with the video with you and one of our support team members working through it. But I was just about to say we've got some questions. So Scotty, you threw one up before I even could. So Sheb, thanks for writing in the question. So question is this: does this only apply to AI overviews, or can it help non-AI overview rankings, and why? I'll throw the "and why" in there.
Yeah. I mean, Chev, so thanks for the question. It's a great answer, great question. We get a lot on these demos that we show people. The way that Market Brew was built back in 2006, if you go to the Market Brew site, you can see our patents that we filed long time ago. We had this idea that we would build this search engine tool so that we could see, business owners could see exactly what was creating or biasing the results, right? So we could it's like a behavioral analysis of the search engine. And everything is built off of the core engine, the sort of the core brain of Google, that everything is built off of, right? So local maps, images, discovery, snippets, all these things. Even AI overviews is sort of an extension to that brain. There are parts of the model that we perhaps don't see, like the dwell times and the stickiness factors, all that stuff. But we have a large enough component of it that we can usually behaviorally characterize what's happening in that model, so that if you're an SEO person, you can see, okay, this is clearly affecting the overall rankings. So we started out by actually just asserting that it was affecting the overall rankings in the beginning. So if you go back a year or so into Market Brew, we were already seeing this as sort of end of 22, we saw this started to affect the rankings very dramatically. And then AI overviews was introduced. And of course, we had the AI overviews visualizer very quickly because we already saw and built these tools internally to build the inputs to all of the algorithms. So we just exposed all that tooling. And that's what you see in these free tools. So you can go in and see exactly what that search engine is seeing and how it's seeing it. But yes, absolutely, Sheb, it is most definitely affecting the overall rankings in 2024 and beyond.
Awesome. We had Devorin write in. I asked for a little bit more clarification from you, Devorin. So if you're there, feel free to throw it in the chat. But this was Devorin's question: wasn't there any drops after the ranking increased at all? So I'm assuming that's maybe going back to the example on corset dresses.
Yeah. So what these models do is they'll sort of ladder you up the ranking. So the first thing that the team actually attacked was the top cluster similarity algorithm, and the reason why is that it seems to be at the top of a lot of our models. So it's the thing that Google, if you think of the Google search engineers, and they have this like a DJ mixing board, right? And so each one of these sliders is a family of algorithms, right? And they're given a quality rater guidelines assessment, right? The humans label the results of how they want Google search results to look, and then we feed it through this unsupervised machine learning process. You can imagine it's basically like search engineers kind of dialing in what those weightings are so that it behaves the way that we were told to make it behave. And so that is essentially what's happening in these models. We're just using that calibrated model to infer what are the things that will move this, whatever target page that you want to pick, what is the path of least resistance up to the top. And so the first thing they just did, and this is a fairly recent case study, first thing they attacked was that top cluster similarity. So the next thing we expect to happen is not a drop. We would expect to continue going from 38 up to the #1 ranking, but it's a sequence of events. There's other optimizations that need to occur before we can get there.
Okay, great. Scott, we don't have any more live questions right now, so let's do this. Why don't we throw that video on? But for the rest of the 18 people out there, if you have any questions, please feel free to throw them in the chat. There is maybe a 15 to 20-second delay from our live to your screen. So during this video, if you have any questions, please feel free to throw that out. And then after the video, we can talk through any of these next steps if you so desire. So Scott, let's play that video and then we'll come back.
Yeah, so Steve, we're going to be, that'll be an outro. So,
oh, never
yeah.
mind. Look at this.
Yes.
This is live, folks. This is what live broadcasting is like. Well, then
we'll do it live.
let's do this. Let's talk through what some possible next steps could be. What we love at Market Brew is helping people. You know, I jokingly said before, like, you don't know what's inside the black box until the airplane crashes. I really don't want your airplane to crash. Like, we have a desire to help companies and enterprise clients and agencies really understand SEO, whether you are entry level SEO and you're working on a project, or whether you've been in the game 20, 25 years like Scott has had. So here's my ask of you. Do you think we can help? If that's the case, just book out a call with me. Like, I'd love to understand your business. I'd love to understand where the challenges have been. Maybe you're kicking butt and you want to just keep kicking butt and you think our tool can continue to increase the rankings for you. Fantastic. Book a call with me that way. But again, our goal is to serve you, the SEO community, in the best way we know how. And so, Scott, thanks for another session. If you guys have more questions after the session, we will be sending out an email to everybody. So just feel free to blow us up. Like, send me an email, call me. I'm an old school guy. Just give me a call on the phone. Send me a text. I'm here to help. So yeah, thanks for tuning in again for another fireside chat. And the hope is that we can continue to help serve you guys in the days to come. So now that we know we're live, Scott, play the video and let's have some fun. Thanks, y'all.
Well, let's roll it. So the pages embedding cluster comes from embeddings, right? So we're converting each 700 character chunk of content into a vector. And then we have all these points in space, right? So there's a bunch of these. Yeah. And we do this k-means calculation to say, group them into 3 groups, right? So now here there's 3 groups, and we take the one that has the most embeddings in that group, and that is the page's top cluster. It's what the page is mostly centered around. And so that top cluster, the snippet that it's about to return, it's not in that top cluster. And so that's like a template issue. Let's say here's the top cluster, and then we've got this point here. This is the embedding that it came back at the highest cosine similarity. Yeah, it's here, right? So like this is the top embedding chunk. It's pulling this back as like the highest match to core set prom dresses
for that page's content.
Yeah, yeah, it's the most relevant. So like, look at the similarity, right? So the red means the top cluster, doesn't mean like the highest cosine similarity here. So this is the highest cosine similarity. It's always larger font than the rest of the chunks. That's how you know which one's the top one. And you can see 60% to core set prom dresses. This would have been all well and good, but Google has added this condition which says, just check, make sure that the page is about this, right? That it's in the top cluster, and it's not. You can see the top cluster, it's the red, right? So it's these things. We have all the data now, right? We can see all the chunks of content that is in the top cluster, and we can see the chunk that it pulled back. And so now we just ask a large language model, like, tell us how to align it, right? Do we need to bring the page into alignment with this, or do we need to take this piece of chunk and put it into the top cluster? So that's what we do. We do both. We say, here's the differences, right? So the first thing is the differences. And then we also point out like the structure of it as well as the keywords. And then we say, here's to make the target embedding part of the top cluster, do this. Or if the page's top cluster needs a realignment, do this. This is the top chunk of content is really just the navigation. It's just listing out all of the like the dresses and all that stuff. Copy it all in and make the content more about how corset dresses stack up against other dresses, not about how it fits into homecoming, prom, etc. The topic cluster needs realignment. I just want you to get an idea of like my brain space of like how I'm doing this, but here it is. So it just outputs this out. And so now look at this, it's totally different, right? So instead of talking about like, now we're immediately getting to, we have a diverse collection of core set dresses, and we're talking about more dresses. So we're talking about dresses versus different other, why is it different than other liner shift dresses? And all of this here, if we were to put this in here, let's just do that. So let's just start right here. We're going to go all the way down. We know this is all the rest of the content, so it doesn't really matter. I'm just going to paste this in. Okay, here we are. So now we have the new content. I'm going to click on Update AI Overviews Visualizer. So here, now look at that. It's not part of the top cluster anymore. That fixed it. Oh my goodness.
Wait a minute.
It's too easy.
The coloring is how similar it is.
So yeah, so the if you look at the cluster analysis, this used to be blue, right? This was blue. This is at the bottom now. Now, because the top cluster is all about comparing the addresses, it's actually a lot further up, closer to the top cluster now, because it's the top cluster is about, you know, just addresses. This isn't important anymore because it's not the top chunk of content that matches.
Okay, so we pulled it more towards what it should be related, similar to now.
We did, because look, this is where the top one is 60.81. It beat out that top chunk by a little bit percentage, right? This one is now 60.74. So now we've done it. This chunk of content was even better than just listing out addresses. Like literally just, you know, what we thought could have been the best way to do it. Now this is actually even better. And not only did we do that, but we made all of the content, the body of the content of the page about this, right? So it's more about core set addresses. This is a cluster tab here. So the cluster, this is just breaking up all of the chunks of content into 3 groups, no matter what. So it's just saying, here's all these dots in the space, right? There's probably like 30 of them on this page.
Most similar to least similar, regardless.
We do a thing called k-means, mathematical calculation that you, given a set of data, you have it group it into 3 groups that are close to, it's like drawing a circle around groups, right? It's mathematically doing that. And then we say, okay, you've got 3 groups here. What's the group that has the most of these dots, these points? What's the second and third? And that's what this is. So you see there's always going to be 3 colors here. And you want to make sure that the top chunk of content that Google likes, which is this one now, is in the top cluster. It's what the page is about. Before we had, this was blue, and this was also the biggest chunk of content. It had the big letters because it was the highest cosine similarity. Now the highest cosine similarity is actually this. And at the same time, we've realigned the page to react higher and more, and give confidence to the AI overview system that pulls these snippets in, that this is a page really all about core set addresses. The highest performing chunk was just listing out addresses. It was just literally our navigation listing all the addresses. And so we know from that that's what Google likes. Like we can see out of the whole page, this is what it would have returned. That's what it likes when that's the keyword that we're searching for. So we just then turned and made the whole page about that, right? We said, okay, change the content so that it's realigned with what we're doing here. Rinse and repeat.